Eureka! Oh, hello. My name is Niels Hendrik David Bohr, and I'm boring. Just kidding. I was born in Copenhagen on October 7th, 1885. You could say science runs in my family. My father was a professor of physiology at Copenhagen University, and my brother became a professor in mathematics. I accomplished many things through many studies, but what I am known for most is developing an atomic model that was more accurate and incorporated in the quantum theory. I'm gonna hand the rest of this presentation over to my two assistants. I'm sure they'll knock your socks off.
Thanks, Niels. Good morning, boys and girls, and teacher. My name is Dr. P. Sullivan Haynes, and I am an Oxford man.
Hey, put a sock in it. And my name is Sir Nike. Today we are going to demonstrate Bohr's atomic model for the hydrogen atom.
This is a very rare and dangerous element.
Actually, it's very common. It's in water.
Oh, well, this here is a very common element.
The reason Bohr chose this element to study is because it only has one electron, which is very ideal for this study.
Now, atoms are very small and can't even be seen with a microscope. So we are going to use a hypothetical atom viewer, an ATER 5000.
Let's take a look.
What you see here is a very accurate, perfectly to scale model of the hydrogen atom. The nucleus contains only one proton and is represented by a red Sour Patch Kid. Hydrogen's one electron is shown with the purple Mike and Ike. The green yarn represents hydrogen's energy levels, and the electrons fill up one energy level before going to the next. The first orbital can only hold 2 electrons. The second holds 8, and the third holds 18 electrons. Electrons stay in their orbital unless they absorb energy, which makes them jump to higher orbitals. This is what Bohr studied with different elements, and what we are going to show today.
A big thanks to our very small friend, Georgia, for that wonderful presentation of an atom, brought to you by the Atom Viewer and ATER 5000. It wasn't a Bohr after all, was it? Bohr. Bohr also used this model for other elements such as nitrogen.
His theory, while not the most accurate, is still used today because it's a simple way of explaining the quantum theory in atoms.
Now it's time for Show What You Know! Who is the scientist we studied today? A. Miss Shoup, B. Albert Einstein, or C. Niels Bohr?
That one's kind of difficult, but I think it's
C.
Niels Bohr.
In reality, hydrogen's nucleus is really made of a Sour Patch Kid. A. True, B. False, or C. All of the above?
The answer is false. It's made of a real proton.
What happens when an electron absorbs energy? A. It disappears. B. It jumps to a higher orbital. Or C. It explodes.
That one is B.
B. It jumps to a higher orbital.